Hello everyone, my name is Mohammed, and in this video I'm gonna give you a brief overview for the paper Cyclical Learning Rates for Training Neural Networks by Leslie and Smith. You could find the link for the original paper on my website. The link is in the description below. It is known that the learning rate is the most important hyperparameter to tune for training deep neural networks. Too small a learning rate will make a training algorithm converge slowly, while too large a learning rate will make the training algorithm diverge. Hence, one must experiment with a variety of learning rates and schedules. This paper describes a new method for setting the learning rate, named Cyclical Learning Rates, CLR, which practically eliminates the need to experimentally find the best values and schedule for the global learning rates. Instead of monotonically decreasing the learning rate, this method lets the learning rate cyclically vary between reasonable boundary values. Training with cyclical learning rates instead of fixed values achieves improved classification accuracy without a need to tune and often in fewer iterations. This paper also describes a simple way to estimate reasonable bounds, linearly increasing the learning rate of the network for a few epochs. As you can see in this picture, the CLR method is way better in accuracy, and you could achieve your desired accuracy with fewer iterations. But how it works? First, cycle length. The training process is divided into cycles, each defined by a step size parameter, which is the number of iterations for half a cycle. Second, linear increase. The learning rate begins at a minimum or base learning rate and increases linearly over a specified number of steps until it reaches a maximum learning rate. Third, linear decrease. The learning rate then decreases linearly with the same constant, returning to the minimum learning rate over the next number of steps, completing the triangle shape. An intuitive understanding of why CLR methods work is that the difficulty in minimizing the loss arises from saddle points rather than poor local minima. Saddle points have small gradients that slow the learning process. However, increasing the learning rate allows more rapid traversal of saddle points plateaus. How can one estimate a good value for the cycle length? The length of a cycle and the input parameter step size can be easily computed from the number of iterations in an epoch. An epoch is calculated by dividing the number of training images by the batch size used. Accuracy results are actually quite robust to cycle length, but experiments show that it is often good to set step size equal to 2 to 10 times the number of iterations in an epoch. How can one estimate reasonable minimum and maximum boundary values? There is a simple way to estimate reasonable minimum and maximum boundary values with one training run of the network for a few epochs. It is a LR range test. Run your model for several epochs while letting the learning rate increase linearly between low and high LR values. This test is enormously valuable whenever you are facing a new architecture or dataset. As you can see in this picture, we are using different learning rates that is linearly increasing. For instance, we could choose our learning rates between these two boundaries because this gives us a high accuracy. In conclusion, a short run of only a few epochs where the learning rate linearly increases is sufficient to estimate boundary learning rates for the CLR policies. Then, a policy where the learning rate cyclically varies between these bounds is sufficient to obtain near optimal classification results, often with fewer iterations. This policy is easy to implement and unlike adaptive learning rate methods, incurs essentially no additional computational expense. Thank you for watching this video. If you like it, please subscribe to my channel, and hit the like button. See you next time.